Hello students, in the today's lecture we will talk about the image derivatives because our main aim of this lecture is to identify the images in terms of the edge detection of an object. So we have one image. I have to first select. Yes. So we have an image, and inside this image we have one object. Suppose this one is object, and we have to identify the edges of this object. What is the edges? The edges is this one. So there are certain algorithms in order to detect these edges, but before learn this algorithm, we have to understand the mathematics first of all. So we have to understand about the image derivatives. So in the today's lecture we will talk about the image derivatives and the image detector algorithms. So what is the derivative? The derivative, the spelling is mistake here, so I will again write. Yes. So what is derivative? Derivative is a term which is dependent on some another term. Like if I want to calculate the derivative of this image in terms of the x coordinate, because I am talking about the two-dimension space, and by default the image having two dimension. So x and y coordinates it will contain. So there should be two derivatives regarding the first coordinate x and the another one is y coordinates. So if I want to calculate the derivatives of an image, then it is represented by ix. So derivative is nothing but a term that is dependent on some another thing. Like the derivative of image is dependent on the initial term that is called only image, and the derivative of y is dependent on again the same term that is I. So basically it depends upon the coordinates, and it is also represented by dou of x, dou of f divided by dou of x, as well as dou of f divided by dou of y. So you can also represent the derivative by using the dou term, else you can use ix or iy in order to represent the derivatives of the particular image in the two-dimension space. And the another term is called image gradient. So what is image gradient? In the more technical term, the image gradient is a directional change in an image regarding the intensity of the color. Like if this is the image and you have to this is the image, and you can see in this image there are a lot of difference. Like there is a blue color, dark blue color, and it is faded towards the upper one, and now there is a white color. So by using the image gradient, we have to calculate the change in the pixel values regarding the direction. So first we have to calculate the change in pixel value with respect to direction. So you can see there are three directions. The first one is this one. Now the pixel value is getting higher here, and it leads to get faded, means lighter in this direction. And the another one you can see from there, like the upper one to the lower term, and the another one you can see like the 45-degree angle, like this way. So there are three directions, and according to these directions we have to calculate the image gradient. So for the equation, this is represented by delta of I, which is the image gradient, and along with this we have to calculate two parameters, the ix and iy. So first we have to calculate the ix, and after it will be transpose, and the matrix of iy will create it. So according to the difference that I told you, we have to calculate the change in the pixel value. So where is the change in the pixel value means we have to calculate the difference from this one to this one. So this is your x position here, fx, and this is your fx plus 1 position, right? Similarly it will happen for the y coordinates also. And also if the image is in the direction having a darker color over there and the lighter color over here, then we have to identify the change in the pixel value by using this direction. Means it will become fx minus 1 and it will become fx. So according to that thing, the image gradient is calculated by using the three parts. The first one is called forward difference, the second one is called backward difference, and the third one is called central difference value. So for calculating the gradient, we have to depend upon these three differences, and from these three differences automatically my derivative of image of x and the derivative of y will automatically calculate it. How it is calculated, that we will see. Like the first forward difference, is one of the example, this one, the forward difference, this one, this is called forward difference. So the equation can be written as fx plus 1 minus fx. Like the same ways, the backward difference is in the opposite direction of the forward difference and it is calculated by fx minus 1, right? And the third one is called central difference. So central difference is just the average value, and for the formula we have to write it fx plus 1 minus fx minus 1. So in terms of the value, because we are talking about the two-dimensional spaces, and also before applying to this edge detector algorithm, it is mandatory to convert your color images into the grayscale images. So grayscale images having only the two colors, that is black and white, and it is very useful for the Windows storage system. So if there are only two colors, 0 and 1, then this x and y value will be represented in the terms of 0 and 1. And if there is a coordinates in the negative direction, it will be indicated as minus 1. So this fx1 and minus fx will be represented by this and this one, and fx and fx minus 1 will be represented by minus 1 and 1, and this value is represented by 1, 0 and minus 1. Means the value having the backward direction, like this one. If we are finding the change in value from there to there, then this value, the value over this one is indicated as fx minus 1, and the value over this one is indicated as fx. So this one be the negative value minus 1, and this will be the positive value, that is plus 1. In the upper one case, this one will be the negative value, that is minus 1, and this one will be the positive value, that is plus 1. So like the same ways, we have to put the values over there for the fx1 and fx. Now for creation of the matrix, we have to combine all of these differences, like the forward difference, backward difference and the central difference. So there is one technique that we have to combine all of the positive values in one column, all of the zeros in another column, and all of the negatives in another column. So first I have to choose the positive values. So 1, 1, 1 will be in the one column, all the zeros will be in the another column, and all the negative values will be lie on the last column. Because I am calculated these changes with respect to the x coordinates only, so this one will be your kernel, or you can say sometimes it is called mask, kernel, mask, or sometimes it is called filter. Like the same way you have to calculate the value of y. So what should be the value of y in this case? The value of y will be the transpose of this. So all of the rows will become the columns and columns will become the rows. So now your kernel and mask is ready for the use. And also we have to calculate the derivatives, because our more important task is to calculate the ix and iy. Now my mask is ready, my image matrix is ready, and what is the formula for calculating ix and iy? So calculation of these image derivatives comes under the category of convolution, that is called image convolution. So what is image convolution? Image convolution is used to do some padding bits, is used to add some padding bits inside the image, and it is useful to detect the edges of object, sometimes the motions and the pose estimation. So because we are talking about only the basic term, the image convolution is a technique in which I have to identify the value of ix by multiplying the mask or kernel or a filter with the image matrix. What is the image matrix? I already created image matrix like the first. You have to make an object of an image, then you have to apply the flatten function over there, and all of the things have to be converted into the one dimension space. You can convert it into the two dimensions also in the matrix form, and then you have to multiply with the mask, and your ix, the value of derivative in the direction of x of an image, will be calculated. Like the same way you have to calculate the iy also. So what is image convolution? The definition of the image convolution is, it is defined as the sum of product of the corresponding elements of the kernel matrix. Kernel matrix is this mask of the elements of kernel matrix to an image matrix, that is again called the grayscale image. So this technique is very useful in the edge detector algorithm that we will see in few of minutes. So the utilization of this image convolution is used to do filtering as well as padding inside the image. And one of the technique under the image convolution is called Gaussian blurring images. One of the application you can say, one of the technique you can say. So Gaussian blurring images. So it is again the requirement that you have to convert your colored image into the grayscale first and convert it into the two-dimension space. Now your image I is ready for the execution. Now there are some noises inside the image, like the camera is capturing the image which have some noise. So first you have to denoise your image. So how to denoise? You have to apply the Gaussian filter technique over there, and your image will be denoised. So the formula for the Gaussian blurry images is I sigma, your image I, into G and sigma. So what is your I? I is the image in the grayscale format. Which one is this? This is the outcome after the denoising of the image. And this G sigma is called the filter, or you can say kernel, because it is a Gaussian parameter based, so that's why it is called Gaussian kernel. In the format of 2D. And what is the sigma indicates? The sigma is nothing but the standard deviation. So it is observed that when this sigma value is high, then you will get more blurred image. So you have to identify the ideal value of the sigma such that the denoising can be performed, otherwise your image will be blurred in this situation. And what is the formula of G sigma? So G sigma is nothing but the same formula that you have used in the Gaussian distribution. So that is your formula, that is your x and y coordinates, and this is your variance. So there can be many values of the sigma, like for the demo part there is a Jupyter notebook. So from the Jupyter notebook I am using SK image library. So from the SK image we have to import the IO class, and this is called the input output class. First you have to create the object of your image, and you have to identify, you have to tell the compiler that your creating object is of which type. So it is the class type IO, and by using the dot operator you can call the functions. So my function is imread is used to take the or uploading the input from your folders. So this is my folder path, and this is one of the image. I am using the Alia Bhatt image because Alia Bhatt is my favorite actress. So you can use whatever the favorite one images of your daily life. So for the Gaussian blurry images or the Gaussian filter, the one restriction is that you have to first convert your image into the grayscale format. So in the grayscale format you have to import one another class that is called the color. So from that color you have to first read out your image. After the reading you have to make another object, and you have to tell the compiler that this object which of belonging to which class, that is color class. So from the color you have to call the function that is RGB color space is converting into the grayscale image. So from the RGB color space it will be automatically converted into the grayscale color spaces from this function, that is RBG2 and gray, and inside this you have to pass the object name. So from passing this object name and IMShow method, the Alia Bhatt images will be converted into the gray format, that is called the grayscale image. Now apply the Gaussian filter. So because Python is a very useful library and it is very simple one, it will provide you a direct functionality. You can use just direct functions and take the advantage over it. So first you have to import the filters, and from the filters you have to make the object, and after making the object you have to use a dot operator in order to invoke a function. So Gaussian underscore filter is a function in which you have to provide the image object comma 20. So this 20 is known as your standard deviation sigma. You can try for the another values also, like 2, 5 and 10. So I will send you the code. You can play with these images and test for all of the values of sigma. So this is one of the demo for the Gaussian filter images. Now we jump to the another one that is called the image detector algorithms. So edge detector algorithm we having two things. The first one is called Sobel edge detector algorithm, and the second one is called Canny edge detector algorithm. So we will see the first one, that is called the Sobel edge detector, which is very simple to understand. Why it is called Sobel? Because the kernel or mask is used for do the convolution techniques is known as Sobel kernel. That's why it is called Sobel edge detector algorithm. So the idea behind the Sobel edge detector algorithm is to find out the pixel with having a large magnitude of the gradient values. To find out the pixels of an image with having a large magnitude of gradient value. So what is gradient? That we already know. So that is the formula for the gradient, that is ix comma iy, and you have to make the transpose. How can we calculate the magnitude of gradient values? For calculation of the gradient magnitude, the formula is you have to take the square of this, and the square of this means I of x square plus I of y square. In the more technical term, you can say you have to take the square of x derivative of x and the y derivative of x, and you have to use the square root, and this is called the magnitude of gradient value. So in the more technical term, you can say that it is the root of sum of squares of image derivative in x and y directions. Because gradient is dependent on two things. The first one is called the image derivative and the second one is called the direction. So derivative you can find ix and iy, and where it is find that is already told by me, but how to find the direction? The direction or the value of theta, the formula is tan inverse I of y divided by I of x. Right? So this derivative, that is ix and iy, is fixed, or you can say it is a constant for all of the algorithms, and each algorithm can use its own ix and iy. Like the Sobel edge detector algorithm uses the value of ix, or uses the value of kernel. Just I'm manipulating my statement that ix and iy value have to be calculated with the mask into the image value, image matrix, with the mask into the image matrices, and this mask is known as the kernel. In the term of Sobel edge detector algorithm, you can say this is the Sobel filter or a Sobel mask or a Sobel kernel. So what is this value mask? This mask is finalized by the algorithm and it is integrated as a constant value. So for the Sobel edge detector algorithm, it is indicated by dx, and for the y value it is indicated by dy. So because it is a constant, what should be the value? The value is given as -1, -2, -1, 0, 0, 0 and 1, 2, 1. And for the y coordinates, it is given as, the mask is given as 1, 0, -1, 2, 0, -2 and 1, 0, -1. So your mask is ready, your image is ready. You can calculate ix and iy. From this ix and iy you can calculate the magnitude. From that magnitude you can calculate the value of theta also, and from that way your Sobel edge detector will work. And also the first you have to convert your color space images into the grayscale image. So from the Python library it is very simple to implement. It is very simple to implement like this way. So this is my image, that is Alia Bhatt's image. First I have to convert it into the grayscale, and you have to just call the Sobel. So Sobel is Sobel edge detector algorithm by using the Sobel function inside the filter class, and this filter class is the part of the ASCII image library. So you have to pass the object of the gray one image that you have created from the conversion from the color spaces to the gray one, and you have to pass that object inside the parameter, and after the run of that code you can see this image. So from this image it is not so much visible because the Sobel edge detector algorithm is providing not so much accuracy, and it is failed in order to detect the edges inside the object of the image. So in order to mitigate this drawback, another algorithm called Canny edge detector algorithm is applied over there. So what is that algorithm that we will see? So my another algorithm is Canny edge detector algorithm. So the major drawback from the above one, that is Sobel edge detector, is it is not very much efficient in order to detect the images, and also in the Sobel edge detector it does not use the direction. The direction part is not used, only the magnitude part is used. So Canny edge detector is just like the using the concept of Sobel edge detector, but along with the gradient values, but along with the magnitude of gradient values, it has to use the direction also. So that is one of the major difference between the Canny and the Sobel. So there are 4 steps. The first one is called the smoothing. So smoothing is nothing but you have to denoise your image by applying the Gaussian filter. So apply Gaussian filter. The next step is called finding the gradient. So how to find the gradient, magnitude of gradient and the direction, that you already know. The third one is called non-maximal separation. In the non-maximal separation, we have to check whether the gradient, the magnitude of gradient calculating is maximum among the neighboring points lying between the positive and the negative direction. Like if it is the image and this is your object. So first you have to identify one of the coordinates over there and the image coordinates, image object coordinate, or you can say edge coordinate. So your edge coordinates should be maximum as compared to the x and y as well as the upper and lower value, that is x2, y2. So this one in the positive direction and this one in the negative direction. So whenever the point is falling up to the range of this x1, y1, then we can say it is the part of the edge, otherwise it will not be the part of the image. So you have to take the pixel values and judging those pixel values with respect to the neighboring ones in the positive and the negative direction. And your value should be the maximum value with respect to the above one and the negative one. So that is called the non-maximal separation. It is used to correct the errors that the Sobel edge detector algorithm does not utilize. That is the non-maximal separation. That's why it was failed in order to detect the edges of the images. Now the last one is called thresholding. And this type of thresholding is called the hysteresis thresholding. The thresholding is done by 2 parts. The first one is called the lower threshold and the higher one is called the upper threshold. So the restriction is your edges, coordinates or the pixel values of the image should be lie between this range only upper threshold and the lower threshold. The values above the upper threshold will not get accepted as an edge, and also the values which having less than the lower threshold will not get accepted. So it is mandatory that the coordinates or the pixel values of the edge of an object must lie between the upper threshold and the lower threshold. So how to calculate the value of upper threshold and the lower threshold for your images? Because each image having different objects, different colors, so it will not be fixed just like the mask. So what is the criteria? So first you have to define the value of sigma. Value of sigma. According to the value of sigma, suppose I am choosing the value of sigma as 0.2, and after choosing the value of sigma you have to take the median of your image values, median of image. So there is direct technique used by the Python that will convert into the image pixel value in the form of arrays, and from that arrays you can calculate the median. So median of an image, and it is indicated by V. Now for the upper threshold, the formula is you have to calculate Upper threshold means the lighter value. Actually, the white values or the lighter values goes threshold to the 255, and the darker values like black starts from 0. So for the upper threshold, the formula will be taking the minimum of 255, that is the RGB value, 1 plus your sigma value and into your median value. So whatever will be the maximum, it will be treated as the upper threshold. The same scenario will be due for the lower threshold, but the lower threshold will get the maximum value. What should be the maximum value? Lower threshold is 0, 1 minus sigma into the median. So by using this formula, your upper threshold and the lower threshold value will be calculated. So you do not need to calculate these values separately for your image. So there is a automation tool provided by the sklearn and the Python library, that just you have to use the Canny function, and inside the Canny function you have to provide the details of the image, and your edge detection will get successful. Like it is your filters and the feature, you have to import the color because you have to convert it into the grayscale. After the grayscale, from the feature class you have to define the edge object, and inside this feature there is a Canny detection algorithm function. So by using this Canny detection algorithm function, you have to pass two objects. The first one is called the image object, that you converted into the grayscale value, and comma 3. This 3 is used to indicate the value of sigma. Okay, so from this sigma it has successfully detect your edges of your object. Like the Alia Bhatt images, you can see the edge is successfully detected. So now this term we can say the Canny edge detector algorithm is more accurate, as well as giving you a high performance as compared to the Sobel edge detector algorithm. So now it is pretty clear to all of the students that why we calculating all the gradient values, magnitude values, directions values, and what are the convolution techniques, as well as how to detect the image, how to detect the edges inside the image. So this is all for today's session.